Now, what you're going to do, you have this is a two-part question. I'm going to show you something that's going to make your life a little easy. That's why Desmos might be something for us. So 15. Now, here's what we have going on. They gave you, for this problem, actually, you may not need Desmos yet. So what's going to happen? Here's your line. These were the 2 points they gave you. Now to get the slope, remember it's your rise over run. Now, to get the rise over run from these 2 points, this is the first step you got to take. And the quickest way to do it, you count. Now, if you start from 0, 1, here is 0, 1. And on Desmos, you could actually plot those points on the graph too. And then you go to 2, -2, because Desmos, you are going to be permitted. So when you do this type of problem, so first with the rise, that means up or down. So you're either going up or down. Now in this case, we start at 0, 1. Start on the right. Start from the left. Go to the right. Our new point. Did we go up or down? Look at you went down. You went down. How many? Let's count. 1, 2. So we went down. 1, 2, 3. Now, whenever we go down, is that positive or negative? So down 3 is the same as -3. Now, next part. Now, do we go left or right to get to the new point? Okay, so the run is either left or right. In this case, we went to the right. How far to the right? How far to the right? 2. So is that a minus or a +2? Going to the right. +2. Okay, so this is your slope. This is your original slope. All right, now, to get the perpendicular line, so if it's the perpendicular slope, anybody remember from last time? So if we want the perpendicular slope, I'm going to write it here. You want the perpendicular slope. What do we have to do with our original slope? Does anybody remember from last time? Okay, well, you're on the right track. So we'd have to make it opposite. But what's going to happen now? Because when we divide a positive by a negative, we're originally, what's our original sign? Original sign is positive divided by negative is positive divided by negative. When you divide a positive by a negative, you're always
Positive. Negative.
You're originally negative. But here's what's going to happen. What are we going to do with this fraction? Anybody remember for the perpendicular slope? What do we do with this fraction? Anybody remember from last class? Huh? You flip it. I think Cindy and Elmer, I think you both said flip. Or Brooklyn, one of you three said flip. Okay, Richard, all right. Now, here's what's going to happen. What happens? Now, originally it was a negative, but what happens when you do the opposite of a negative? It turns into a positive. So really, in the end, so you flip and change, flip. Flip and change that sign. And then everything becomes positive. So flip and change your sign. And then basically, if you're going, so plot that point. So what's going to happen is you're going to be somewhere on this line, and then, or here. Well, it goes through 2, 1. So what's going to happen is here you go down 2, or you can go up 2, left 3, or you're going to go down 2, up, right, or down, left. I'm sorry. That was a mistake. So that would be your new line. So the new line, so this would help you, but you'd have to go from this point. Make sure. So the perpendicular slope of your line, but it has to go through here. So you'd have to go down, left, or you can go up, right. The line's going to look something like, it's going to look something like this. So that's going to be your new line. But you follow this slope. This tells us to go up 2, right 3. You could also go left, or you can go down left. That would also work. So that would be the point. That's the purpose of this problem. Remember, you could also use Desmos for this problem too. I'm going to show you real quick. In fact, a lot of these you can use Desmos. It's even here. I'm going to show you real quick. Zoom in. What was it? 0, 1. This was one of your points. I don't know if I could ever. Now, you are also going to be allowed to use graph paper. So basically, what's going to happen is you can plot your point, which would be 0, 1. I don't know why it's not giving it to me. Okay, so you can type it in. Oops. All right, this computer's not being my friend right now. Okay, you type in your point, and then you type in your other point. Up, use parentheses. What do you mean? For every number, well, if you're going to plot points, yeah, you're going to have to. And then you can just count. Because then here, you can just count. You went down 1, 2, 3, and then you went to the right 1, 2. But now, what you're going to have to do, yeah, you can label. And then I think it was your other point that was 2, 1. Oops. And then this point right here, you would do something similar. You would go, but then you'd have to flip rather than going down to the right. You go up, right, or you can go down, left, and get to your point. Down, left. Now, you're going to be allowed to use graph paper too. So if you want to use graph paper on this, you're more than welcome. Because I know your final, you're allowed to use graph paper. If you take the SOL, you're allowed to use graph paper too. Same thing here. You can use graph paper for this. The key, go ahead. Yes. 13 and 14 are not part of this problem. We're not going to do those. We're going to go back and talk about them some other time. Okay. They're in School of G. They're right now because I really want to go over some other stuff, especially the stuff we either haven't talked about in a while or not at all. I really want us to focus on the stuff from old stuff. That's going to be another day and time. But yeah, you can do that. You can count, like here, count down. Oh, went down 3, right 2. But then you'd have to do the opposite. Like either up, right, down, left. All right. Now, another thing. Now, this problem is very similar. Here, you have to count. Well, this one's going to be a little different because first you count up. So you count up 1, 2, 3, 4, 5, 6. So it's plus 6. So your rise was 6. And then how far to the right did we go? Let's count. 1, 2, 3. We went to the right 4. So this is your original slope. Now, could you simplify 6 over 4? Check. What was it? Can we simplify 6 over 4? Yeah. 3 over 2. Very good. So that's your original slope. Now we want a perpendicular slope. So what would be the perpendicular slope? What would be a perpendicular slope here? So our perpendicular slope would be, well, your original slope is here, but what do you have to do to your original slope? Huh? No. Flip, and then what else? Well, what's our original sign here? That's going to be your slope. It's going to be -2. So your perpendicular slope is going to be -2 over 3. Now be careful. Some of these, you got to be careful with some of these things. From point to point, you may have to simplify that fraction. Some of them you might not, but some of them you will. So then you have to, so out of these 4, you have to look for who has a slope of -2 over 3. That's what you're looking for. So then check this point. If you go down 2, right 3. Are we on the line here? Well, even if we go down more. Well, if we go down more, all right. Let's say we went down more. Went 3. We went to the right. 1, 2, 3, 4. Is this the same as negative 2/3? No. Boom, cross it out of the game. Then if you look across, choice C, you went down 1, 2, 3. And then we went 1, 2, 3, 4, 5. Cross that out. And we went 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. That's not going to work either. A process of elimination is going to be this one. Because you can go down 2, or even if you went down negative 4, and then you went to the right 6, it's going to, negative 4 over 6 is the same as negative 2 over 3. So yeah, so this one wouldn't work. So by process, there you go. So again, perpendicular, change, flip. That's what you have to do. Change and flip.
Sometimes going to be perpendicular, sometimes going to be original.
No, it's either going to be perpendicular or parallel. Now, if it's parallel, you keep your slope. Parallel lines, same slope. So again, like before, original, perpendicular, you change and flip. So if your slope was negative, you got to make that other slope positive as you flip. If your slope is positive, flip it, make it negative. All right, questions? All right. 17, we're going to skip. Yeah, 17, you're going to skip that because there was something that's missing. So, yes, we're going to skip that. So put an X through 17. All right. 18. Well, if it's parallel, what do we know about parallel? Same slope. So we need to figure out what's the slope of this line. Well, first off, the slope of this line what's the slope of the original slope was, well, how far did we go down from 0, 2? So this is 0, 2. We went down 2. It's going to be minus 2. And then, how far to the right did we go? 4. So original slope, negative 2 over 4. Can you simplify negative 2 over 4?
Negative 2 over 4?
Can you simplify that?
Negative 1/2.
Yeah, you're right, Elmer. It is negative 1/2.
But if you flip it...
Okay. Parallel. Now, I was going to say, if you flip it, all right, I'm sorry. If it's a flip, what happens? I'm sorry, I didn't mean to interrupt. You might have had a good point. If you're flipping it, what happens? Well, if you flip...
It's going to be uneven. Because the numerator is bigger than the denominator.
Okay, and then you could... But then you could simplify that, because if you're told to find a perpendicular slope, you would flip and change your sign. So if it was the case, then the perpendicular slope would be 2 over 1, which is just, what's 2 divided by 1? 2 divided by 1.
2 divided by 1,
2, right. But here we got a parallel slope. So if the original slope is negative 1 over 2, what must the parallel slope also be? Positive or negative?
2. Positive. Negative.
Negative. So then you got to do the same thing. You go down 1, right 2 from point P. Or you can go up 1, left 2. There's your line. Up 1, left 2. So yeah, you either go down 1, then right 2, or could go up 1, and then you have to go left 2. So then your line, oops, will look something like this. So remember, parallel slope, same slopes. Parallel lines have same slopes. I can't tell you how many times we've said that a couple times last time. All right. So that's 18. Now, you're probably like, I'm tired of lines and perpendiculars, right? Okay, well, good news. We're going to talk about other things. So, again, if there's time, we might go back to some of these. I do also have a homework activity that's going to be kind of what we're going to be doing. It's probably as important, if not more important. Okay. Questions before we go on? Again, parallel lines have the same slope. Perpendiculars, that's when you do opposite flip. Because one of your homework problems, I'm going to have a little chart for you. You're going to get a fraction, or maybe a whole number. Flip, change sign. All right. All right. Okay. We're losing a lot of time. Then we need to watch what we say. All right. 19. Now, does anybody remember the relationship you have between these two angles right here? Anybody remember if your two angles are directly across from each other? They're equal to each other. Busted. 30's right here. Let me tell you something. This is 30. Now, what do you need to do? Because on your homework and on your test, you're going to have a similar problem. But you need to first understand this relationship. Because this relationship, vertical angles. So this is a two-part problem. You need to get this part to then get that part, because we focus on this triangle here. See that triangle right there? That's fine. What do we know about the sum of these three angles? What do we know about the sum of these three angles, ladies and gentlemen? They must be add up to 180. So, given this highlighted triangle, yeah, you can do that. So remember, 30 plus 80 plus x, because this was just on your test not that long ago. So then, Richard, you said it. Can we just subtract? Do 180 minus 80 minus 30 equals x? Sure can. $70, very good. That's our value of x. X will be 70 degrees. There you go. That's how you solve for the x. Again, this is the key step right here. You got to understand the vertical angles that are taking place right here. Because in this angle and this angle are going to help you get the final angle. But that's the key step there. Because we talked about vertical angles, and we're going to be dealing with this starting next unit, like after this assessment, like the last couple of weeks. Last couple of weeks we have before the break. We're going to be talking about congruent triangles and how we determine when two triangles are congruent. You have to look at, this is going to be one of the ways. Because you have to know about the vertical angle rule. All right, questions on 19. Okay, 20, forget it for now. Cross that out for right now. However, we might see this down the road. That's actually could be a good finals question, or maybe even an overall down the road review question. So 20 we're going to skip. It's going to be 16 total. 16 total. But I'm going to focus on the ones that we should go over. 21, you could also, don't worry about this. Oh no, you should really know 21. This was from the angle identification from the beginning of Unit 3. You don't have, but I'm not going to focus on this because I want to focus on the stuff that you're either going to see in a quiz or the eCart activity. Like, I want to focus on the questions that I know that you'll see and stuff we haven't talked about in a while or at all. So 21, that's an X. Right, yeah. It's like 2-7 alternate exterior, 1-5 corresponding, 4-6 consecutive interiors. This particular problem, no, but something similar is going to be on it, and I'm going to show you with the next couple problems. Where's your agenda? All right. Now I know on your quiz or test, these symbols didn't show up, but these are supposed to be angles. Put angle, and that's degree. Now, before you go, Elmer, I really want you to look at this one. But I also want you to see what's going on here. Now, the goal is we want to prove that these two lines are parallel. So we need to figure out which 4 of these 6 statements work. Yep. So we need to figure out which 4 out of 6 would make these lines parallel to each other. Okay, here's what we're going to do. We're going to go case by case. No. But remember, the goal is we want to make sure these two lines are parallel. Now, they say angle 1 plus angle 2 is 180. Now, in this diagram, it's true, but even though this is a true statement, that only works for the first line here. Does that even include anything from the second line? No. So could this be a possible option? No. Even though it's a true statement, angle 1 and 2 are over here. They don't even consider P and Q or the other line. That's only with one line. So that's why we have to cross that one out. So only one line. That's why you got to cross that out. Hey, D, on the other hand, now if these lines are true, notice, well, be careful. Angle 2 is from this line, but angle 3 is from the other. Even though they're in the same line, but they're dealing with two other lines. They're dealing with, but notice how angle 2 deals with P, right? Angle 3 also touches Q. Now, if we were thinking about any set of parallel lines, let's say if it was these two right here, that's more, because what's the relationship going on with angle 2 and 3? These lines are parallel. What must the sum of these two add up to be? Yeah, this one actually works. That's consecutive interior angles. So part B, consecutive interiors. That's why that works. Now, we didn't talk about this one too much. Yeah, angle 1 and angle 4, that would also work because it was that consecutive exterior, same side exterior angle. We didn't really talk about that one too much, but that could be an option because again, angle 1 touches P, angle 4 touches Q, but this angle plus this angle out here must add up to 180. So that was the same side exterior. We didn't really talk about it too much, but that one would work. Now, 3 and 8, they're congruent, but they're vertical. However, the 3 and 8, they only deal with line Q. Is there any relationship between line Q and line P? For 3 and 8, no. Even though it's true, that's not going to work. It's true, they're verticals, but you can't use vertical angles. Vertical angles, but that's not going to help us here. That's why we got to cross that one out. Now, does anybody remember the relationship between angle 1 and angle 8? Somebody said it. What type? Alternate exterior. That's going to work. And then 5 and 7, that's going to work because 5 and 7 are, begins with a C, corresponding. Oh, my spelling's not the best. Corresponding angles. Questions. So that's how we would do. I'm like 22, that's what you do. Now 23 is going to be similar to 22. Now, even though it said 3, it's really only, it's only going to be 2. Only 2 lines are going to work for that. All right, only 2 will work here. And here's how you're going to do this. Goes back to our linear pairs. Now, we start with 155. What will be the angle measured? Here and here? Huh? Think about a line. I'm going to blow it up a little. Let's talk about the very first one. I'm going to blow it up. I have a 155. This is given to you. It's going to be Y25. Yup. It's 180 minus 155. That's how you get that angle. And then same thing here. They're going to fool you because they're going to want you to think it's this number. You can't do that. You got to focus only what's between. What makes this line 180? Who cares about this number? This number's out to fool you. Because if this angle's 55, then this one's going to be 125. 125. Would these two lines work? Could they be parallel lines? No, they're not going to work. So J and K will not work. Since these two numbers don't add up to 180, J and K are not parallel. However, with line J, think about line M. Now, this angle right here, if this angle's 25, what must this angle be? Or that angle be? What must the sum of these two angles add up to be?
180.
180. So this has to be 155.
Again.
Yeah. It's 155 plus 25 is 180. Now, so line J is not going to work with line K. That's out of the game. Could line J work with line M?
No.
Be careful.
Yes.
Why?
Oh no, you just said no. You said no. Oh, because it has.
A couple reasons.
But it doesn't have the same number.
Who doesn't have to? Oh, M and J. Look at M. Look at J.
Yeah, but that one has $155.25.
But that's okay because they add up to 180. See this angle, 155? Then what must this angle be? That's also 155. Are those two numbers the same as these two numbers? In the same order? Yeah. J's going to work with M. However, it's not going to work with R because we need to figure out what this number is. So you have to do 180 minus 135. But what's 180 minus 135? Sorry, my penmanship's so little bad. In fact, I'll type it. What's 180 minus 135? 45. This is 45. Right, this one's not going to work.
So it'd be that.
So which two lines? M and J. Now you might have, Your test might be 2, it might be 3. Yeah, so J and M would work. Now your test is either going to be 2 or 3, but you still do the same thing. Set up your linear pairs. Then you have to figure out who matches with who. If they match, you got it. If they don't match, cross it out. That's how you do these types of problems. Because notice how J and K didn't work, because 155, 25, but this is 125 and 55. That didn't work. It was here, you got 155, 25. This worked here. Here it wouldn't, because again, you have 25, 155. This would have been a 45, 135. Those two wouldn't work. So you're looking at the combinations. But you're going to do that for all your lines. So you're going to be given up to 4 lines. You're going to have to do that combination for all 4 of your lines. And if the combinations are the same, the lines are parallel. Different, not parallel. So yeah, your answer would be J and M. So J and M would be the ones. All right. Moving on. All right. I'm going to cross out 24. Somebody's out. You got to wait. '24, there wasn't enough information, so plus, you're not going to see this one anyway. That's a cross it. Just cross it out. Okay. 25. It's supposed to be parallel lines. But we talked about this. If the lines are parallel, well, you got one of 2 options. The key is our setup. Okay, now you can write your pairs. Well, first off, for 25, what type of angles do we have? It's going to be hurry up, hurry up, hurry up, because you better hurry up. Yeah. Because she's got to go next. And then same thing. If he comes back, it's going to be hurry up, hurry up. You got it? Okay. That pass has to be written. Okay, 25. I think somebody said it. Consecutive interiors, very good. These are consecutive interiors. So 25. Yes, this is a consecutive interior angles. Add up to 180. Very good. So then what would be our setup for this problem? What's our setup for this problem then? We want to solve for, in this case, y. What would be our setup? Of y minus 7 plus 2y plus 12. Okay, what's left? What do we need? That's your setup. There's your setup. And I think we're at a point you all can solve for this. You've done plenty of practice. Good. I'll give you the answer. You're going to do this one on your own. Just remember, combine your like terms. No, you add them up. No multiplying here.
Will make what, Mr.?
Huh?
It says find the value of y which will make.
Yep, and this is, so you just solve for y. But that's all you do. Since they're consecutive interiors, they add up to 180, and then you solve for y. So now you could check it. Right, and you should, when all is said and done, you should get 180. So whatever this angle is plus this angle must add up to 180. And that's the way you check. Good. All right, questions? So that one I'm not even going to... So I'm not going to talk about that one anymore. You all should know that one. Yeah. Yeah, 25 is 25. Huh? Oh. Oh. No, it's 7. No, time out. Stop. 5 plus 2. 7. 5 plus 2, 7. That should have been a 7 Y. Uh-huh.
Alright, so let's say this. And that's after we do this.
Yeah.
That's for that. And then we get y equals 2. So what happens to 12?
Because remember, 12 and negative 7, they combine.
Oh.
That's something we've done long time before today.
That's how you get 5, right?
Yeah, that's how you get the 5. It's all right. That's where we get the 5. Well, it was supposed to have been 7y, who's 175, not 5y. Okay, 26, similar to 25, but what's the difference here? What type of angles do we have? What type of angles do we have? Well, I want one of you two to answer this one.
Parallel line.
Okay, we got parallel lines, but again,
No, they're interior.
what type of material?
I know alternate interior.
Alternate interior. Alternate interior angles. And what's their relationship?
They add up to 180. No, wait, no,
They're congruent. This might be something to review. We went over these types of problems. Remember, you want X's on one side. And then after you move that X, then you take...
So what you do to one side, you do to the other.
Exactly. In fact, we did this exact problem in the past. Well, I'm going to cheat a little. Well, it's a rewind. This is stuff we've been doing a lot during Unit 3, maybe a little bit of Unit 4, towards the end of Unit 1. It's 5x equals 40. And x, yup. For x is 8.
Awesome.
Yeah, well, there you go. There's your setup. Okay. Now, you're not going to have to do 27. I'm not going to have you do 27 only because you know how to do 25. 27 is exactly like 25. So you're not going to have to do it. If you want to try it, fine by me. But you don't have to do it. So I'm not expecting you to do this problem. So if you want to try it, go for it. If not, 27, just like 25. I'm not going to worry about that because I want to worry about a few things on the next page. Right. They're both going to add up to 180.
Are we doing 27 by ourselves?
You can try 27. You don't have to do it. If you want to try it, but I'm not going to go over it because you know how to do 25. 27 is the exact same. I don't want to worry about something you already know or should know by now. So,
It's the same, right?
which one? 27 is like 25. Consecutive interiors. So, the only difference is your setup. You're just going to replace 5y minus 7 plus 2y plus 12 with the 3x minus 10 plus 5x plus 30. Those guys add up to 180. But that's all I'm going to talk about for that one. That's stuff you should know by now. We've done it more than plenty of times. All right, next page I'm going to talk about. All right. Now, this stuff we really didn't talk too much about. And these were your logic statements because they use a lot of logic statements as, when we're doing like various different things. So this is going to be totally different. Now, the key is, a lot of it is, you're just replacing a phrase with a letter. Like an entire phrase with a single letter. But then it's going to be, what do these symbols represent? And I will tell you what these symbols represent. The first one, if you see an arrow going both ways, that's the same as if and only if. That's the first one. So if you see an arrow that goes both ways, you see this arrow, just a single arrow going one way. You're just in time. You're there, you're back. You better hurry up because they're going to be closing them down real soon. Okay, this one. See this arrow? That's basically saying if, then. Like if you see just a single arrow, that means, in this case, it'll be if P, comma, then Q. Now, P and Q are going to represent certain statements. So I should have said here, arrow that goes both ways means P, if, and only if. Because all you're doing is just going to translate one of these. Now, other things I want to talk about. You see this 3-dot symbol? You see the three dots? That's the symbol for therefore. We haven't talked too much about this at all. So if you see them 3 dots in the triangle, that means therefore. Now, if you see this symbol right here, you see this symbol right here, that's the symbol for and. Last but not least, you see this symbol. That's a symbol for the word or. Basically, so really, yeah. There's going to be a question like this on your little eCart thing. I just want you to be prepared. And we might be going back to this later in the year. I know we didn't talk too much about it, but that's why I'm just doing a very quick. Now, on your homework, there will be a problem like this. But all you're doing is translate. And here's how you translate. And this is going to be, it's actually much easier than you think. This part right here. They said A is obtuse, but that's represented by the letter P. Now, the if and only if part. Which symbol represented out of all these symbols up here? Which symbol represented the if and only if? The both way arrow. Good. And then B is obtuse. That's represented by the Q phrase. So really, your final answer, if you want to write the symbols, there's your P. Is that both two-way arrow? And you're done. That's all you have to do. You're just translating from words and phrases to letters and symbols. That's all it is. Now, we'll be down the road, we'd have to talk about true, false, all that, but we don't have to worry about that. That can get confusing. This is just translation. It's sort of like what we've been doing with problems. Given a problem, diagram, how do we translate it into an equation? All right. So similarly, A is obtuse. Well, which letter represents A is obtuse? P or Q? A.
And it's four, so the arrow's pointing down. And it's P, the arrow pointing down, and another P.
P, arrow down, and well, B is obtuse. So B is obtuse. What letter is that? Q. So again, all you're doing is just translate. Now the last one, well, the first word is therefore. Which symbol represented the word therefore? The 3 dots. going to be therefore. Now, which letter was A is obtuse?
And then you can do the arrow going up.
You do the arrow going up. Where are you?
Where it says P, V, P, V, Q.
P, V, and then that's a Q. Sorry about that. Let me make that Q more like a Q. But that's all you're doing. All you're doing is just translating. If you understand what these symbols represent, or what the words mean, and how to translate from the word to the symbol, you actually got this. You actually do. You actually know more than you think. Because all you're doing is just translate. All right. Questions? All right. Now, what we're going to do, so we're actually just going to work on this. So whatever's left on this page, then we're going to talk about some homework problems. Well, this is going to help you prepare. Right. What's that? That, yes, but it turned out the homework assignment that I had was all wrong. That's why I'm glad you told me the homework assignment that was originally going to be given to you all. I just realized I had the wrong assignment. So that's why I'm going to be a little more lenient on the due date.
So we don't get homework till next week?
You're going to get it today. Not, good try, but not. You're going to get it today. Now, this will help you prepare. If you use the notes, there might be a little bit of time we might go over the homework, like now or in before the class test starts. All right. So, next thing I want to talk about, converse statement. Converse, basically, you're switching order of the phrases. So here, converse statement, that is basically you are switching the order of the statements. That's what converse. So if you see the word converse, that means you're switching the order of the statements. So we'll do an example. So the first one, this is the original. Converse is actually going to be the following. So rather than the two angles of complementary comes first, what am I going to write first for the converse statement? Now, you'll still start with an if, but am I going to write two angles are complementary, or am I going to write if the sum of the measures is 90 degrees? The sum of the measures is 90. Then the two angles are complementary. Now, is that true? Yeah, this is true. That is true. That one's true. You don't have to write it out. Now, you could just, if you just want to do arrows, that's fine. What about the second one? If the what measures? Huh? Okay. What am I going to put first for the second problem? Second example. So what's my first
The
step?
sum of the measure is 89 degrees.
It measures or it should say the angle measures 89 degrees. If the angle measures 89 degrees, then it is an acute angle. Now, is that true? If an angle is 89 degrees, is it an acute angle? Yes, that's true too. But what about C? Let's think about that convert.
Angle, if the angles are very good, then
You're right.
the two angles are the same.
Is that true? Yeah. So if the two angles are congruent, then they have the same measure. Yes, that is true. Again, the converse I'm going to put in red. That is also true. So if the first three are true, then would the last one be true? Well, be careful.
No.
No, because you could write. So if it has four sides, is it necessarily a square? If it has four sides, then it is a. Is that necessarily true? No, because even though you have a four-sided polygon, not all four-sided polygons are squares. Because what about a rectangle? Does a rectangle have four sides? Rectangles have four sides. So, no, it's not. So that may not be true. So you have to look at when you switch a statement, is it true? So in this case, this one's not going to be true. So when they want the false, so you converse switch and then check if it's true or false. Check if converse is true or false. That's what you have to do. So this is two parts. One, switch your order, and then check if it's true or false. If the statement could be true, then leave it alone. But it could be false. So be careful. Now, 30 is similar to 29. So if you get up late, you miss your first class. So the converse.
If you got up late, if you got up late, you miss your first class.
So then what would be the converse?
If you get up late, you miss your first class.
Okay, so then which one of these represents the converse? So
Hey, you missed your first class. You got up late. If you know if you did not get up late, then you would not miss your first class. So it'd be B.
well, remember converse, you just switch.
If you miss your first class, if you got up late.
That's all you do. Just switch. So it's just switch order of the statements. I think what you said, if you did not get up late, yeah, you said you said the inverse. You didn't, then you will not miss. Yeah, you said, so that middle one was the inverse, and then that last one was contrapositive, but converse, that's all we're worried about. Now, last thing I want to talk about. Now, the last page, don't worry about the last page, but I want to talk about this very last problem on this page. Counterexample. Counterexample. This is when you're proving something wrong. Something incorrect, I should say. That's what they mean. So here, they're saying n to the third power is always less than n. So this is n. They're saying this is always, well, they're saying then n to the third is always less than n. So they're saying that n is always going to be greater than n to the third. But is that necessarily true? The first one's definitely not necessarily true, because what's really happening here? If you take -1 to the third power, what do you get? We're not done yet.
-3.
Uh-uh.
Oh, -3.
It's -1. Now, is -1 always less than, or is n, well, this should have went the other way. I should have said it. All right, they're saying this. But is -1 always less than -1? In fact, let me erase this part right here. Sorry, I confused you all a little. Okay, well, problem solved. Let's do it this way. N to the third, always less than n. That's what they're saying here. I'll give it to you when I'm ready. I'm not ready.
I'm just joking, man. Alright, keep going. How about it?
And I'm just saying, there's going to be cases, but that's basically what's going on with a counterexample. So they're saying this is always less than n, but that's not true. Because in case number 1, they were equal. So that's no good.